say that I need to be saved. Say with me, the devil got his way. I want to know how when you are praying, when you are doomsdaying, how you think you know that someone is listening to what you are saying. So you think that you can tell us how to live our life, never questioning the source from which your moral code derives. You think that suffering is part of some great plan that's been devised. I wonder when we'll be rid of your life.
Well, welcome back, everybody, to the Open Air Atheist Podcast. The song you just heard was by Shelley Segal, entitled Saved, off her debut album, An Atheist Album, which is pretty much now the Open Air Atheist Podcast theme song. Actually, if Shelley here, she's going to be the co-host for this episode. And here with me tonight is Professor, theoretical physicist, Lawrence M Krauss, author of many fine books. One we're going to be talking about in this episode is The Universe, A Universe from Nothing. So, Lawrence.
Nice to be there virtually.
Yes.
Hi, everyone.
And Shelley, it's so good to have you back on the show.
Thanks for having me.
No problem. So, man, it's just really good that you're here, and actually Lawrence was late because of Dawkins. It's all his fault.
It's always good to blame things on Richard.
Yes. Richard, you'll be getting some angry emails from me later.
It wasn't his fault, it was the plane. So it's okay.
It was the plane? Okay. So, all right, first thing. Universe from nothing. Are we talking about from non-ontology here? I mean, when we say nothing, are we talking about non-existence in every sense of the word, or?
Oh, what do you mean by non-existence? The answer is yes, I believe. I mean, what amazes me is that I get these questions from philosophers and theologians telling me, well, you don't really understand nothing, the philosopher's nothing, and in the book I retorted by saying, well, theologians and philosophers are experts at nothing. But point is that, look, nothing is I don't understand what philosophers mean when they say non-being. What do you mean by non-being? To me, this is a physical question. And in the absolute sense, absolutely non-being. It didn't exist before. It exists now. It's in the same sense of non-being that, to use a very familiar example, I think, that, the light in your room, which is illuminating your computer or your phone or whatever you're using, think of that. So they're atoms, and the light gets emitted by those atoms when electrons bounce from one energy state in the atom to the other. But the light didn't exist before the electrons emitted it. I mean, it wasn't as if it was there. It was spontaneously created. There weren't particles of light hiding within the electrons waiting to get out. And that's the way, what I'm talking about, a universe that literally did not exist. And of course, what I've done at length in this book, because I anticipated this problem, because I've talked about it a lot. First of all, let me just say, the book is more a celebration of the wonder of the universe than it is an effort to try and argue against God. The book is a celebration of what we've learned about the amazing universe. And of course, what we've learned is far more fascinating than any myths that humans have created. But one of the things that is remarkable about what we've learned is that not only is it plausible that the universe was created from nothing, but all the signs suggest it probably was. Now, what do you say nothing? Well, for the first kind of nothing that I mention is the kind of nothing that I think the ancient philosophers would have described as nothing, namely empty space, nothing there, an eternal void, like the Bible. And that kind of nothing, of course, is not nothing at all in the modern world. It's because empty space is a boiling, bubbling brew of virtual particles that pop in and out of existence. And the first thing after I describe the universe, which I'm happy to do at some point in this talk if you want. But after I do that, I point out that in fact, given the laws of physics as we understand them, nothing is unstable. Namely, empty space will always create something. By quantum processes, particles will appear and remain in appearance once you add gravity. You can start out with an empty universe that fills itself up with stuff, and there's no sneaky business here. It doesn't violate the laws of conservation of energy or anything else, because gravity can allow for negative energy as well as positive energy. So empty space can create stuff all the time. Now, when I tell people that, suddenly that is no longer their good enough kind of nothing, because it's too easy to make something out of it. They say, well, that's not nothing, because you've still got space there, and the space is something. And then I say, well, once you allow quantum mechanics and gravity to come together, then in fact, as far as we can tell, space itself can be created from nothing. You could start with no space and no time and create a universe full with space and time. And to me, of course, that's pretty darn close to nothing. But then they'll say, well, that's not nothing either, because the laws existed. The laws allow you to create are there, and then you need a creator for those. And then the last part of the book, I talk about how even the laws of physics as we now understand them may themselves be accidental and random and not prescribed in any way. And they may just be the way they are, because if they were any different, we wouldn't be here to measure them. And it's something called the anthropic principle. I don't particularly like it, but it might be true. And so in that case, even the laws themselves come from nothing. And that's about as close to the kind of nothing that I can consider. And the philosophers or theologians may not be happy with that nothing, but I'm convinced that the reason they won't be is they define nothing to be that from which only God can create something. But that means nothing to me.
Well, yeah. I think their concept of nothing isn't really... I mean, nothing doesn't exist, at least the nothing they're talking about. It is non-existence. You can't even conceptualize it because there's nothing to conceptualize. There's nothing to visualize. It's absolutely nothing. And I think the kind of nothing that you're talking about is a little bit different. Correct me if I'm wrong. I don't think nothing in their sense exists, nor has it ever existed, because if it did, it wouldn't be nothing. And so I think the whole the thing is just kind of ludicrous.
Well, I think it's ludicrous because bottom line is what I'm trying to say is that science has changed the playing field from which we can even ask the questions. And these questions are scientific ones, not philosophical or theological ones. And when it comes down to it, in a scientific sense, those terms and those worries don't matter. The question is, how did our universe arise? What physical processes might have caused it? And how can we test them? And those are the questions that are much more interesting. The question, why is there something rather than nothing, is really an ancient question that really is no more. It's like asking the question, why are there 5 planets? As they used to ask. It used to be profound, and it used to be felt, well, maybe the Platonic solids would somehow give some profound reason why nature had chosen 5 planets. Now we know it's just an accident of our existence, and they're not 5 planets. They're 9, because I consider Pluto a planet, and I always will. And we understand it's just an accident. There are solar systems with more planets and fewer planets. There's nothing profound about it. It's changed the playing field. So the questions that were once interesting are no longer interesting. And while they may be interesting to theologians and philosophers, they're interesting to them precisely because those fields have not evolved in 2,000 years.
Right. I like your debate style, because especially with William Lane Craig, where you started off your debate by saying, you know what, I really, you seem to have this attitude where I don't really think anybody's convinced by these things, so I'm just going to go ahead and teach you some science. And I thought that was really cool. If nothing else, I'm just going to teach you some science.
Other people didn't feel so good about it, but yeah. I'm glad you did. But I think, because actually, I think that's, first of all, thank you, but it's a debate I've had with my friend Richard Dawkins. In fact, my interest isn't destroying religion. I mean, if that happens as a side effect, that's fine. But my interest is explaining how the universe works to people, and that's all I care about.
Right.
I don't want to live with myths and fabrications when the real thing is so much more exciting.
Right. Well, I mean... oh, sorry. Go ahead.
just kind of have a question to do with that. I was in the Natural History Museum in the States, and I was in the evolution section, and there was a big video screen with Francis Collins talking about how religion and science are not incompatible. And I found it quite horrible that it was in this department that they had that kind of accommodation as talking. And I wondered how you felt about that, and how you felt about scientists kind of accommodating religion. It might be a cost, but at least kids and adults will be exposed to science and scientific ideas, even if it is looking at it through the realm of religion.
Well, I think I can understand the reasons. I've been called an accommodationist at times, although fewer and fewer times.
Oh.
But because I look, there's a great pressure here not to alienate people, and so I think when I go to fundamentalist colleges, I've even said it on Fox TV here in the States, when I say you don't have to be an atheist to believe in evolution, because it's true. It's a plain fact, because I have colleagues of mine who are deeply religious, but they accept evolution. So just as a matter of fact, it's clear you don't have to be an atheist to believe in evolution. And that is profoundly important, because I meet these kids who tell me, wow, no one's ever told me that. I always thought science was akin to atheism. And it isn't. The point is, God is irrelevant to science and largely never discussed. And so, you don't... I think it's important to point out to people that the universe is the way it is, whether you like it or not. And then if you want to impose your own weird beliefs on it, that's up to you. But the fundamental point is that evolution happened whether you liked it or not. And if somehow your belief in God is only palatable to you, if an evolution didn't happen, then you better give up your belief in God. And so I think I can understand and especially in this country, which is so sensitive, where people are told science is atheism, and therefore science is bad, and therefore science is wrong. Then what you're doing is you're countering this perception that science is akin to atheism, and therefore people should never listen to scientists. And if you want people to listen to you, hitting them on the head is not always the best. Sometimes it's useful, but as I like to tell Richard, I think you don't. If you want someone to listen to you, probably the best thing way to start the conversation is not as follows. You're an idiot, and everything you believe is wrong. And by the way, to tell you what's right. And so they're likely to come off before that point. So, while I think it's important to be honest about the fact that science doesn't have to destroy your faith, because for some people it doesn't, and why it doesn't, I can't quite understand, but it certainly doesn't. But at the same time, I think you should be honest and say, well, there is that science is inconsistent with all of the world's religions. That you can be a deist and believe there's some overwhelming intelligence in the universe that I can't disprove, although there's no evidence for it. But for sure, the doctrines of Judaism and Christianity and Mormonism and Muslim and Islam and Buddhism are all inconsistent with science.
Yeah, I really like your book. So far, I mean, I haven't read the whole thing because I just got it in the mail a couple days ago.
Well, usually when I like to tell people, the main thing is buying it, not reading it. But anyway.
Well, I really like it because it's really accessible. Like I was reading the Grand Design, and it's pretty lofty. I'm not a scientist. I'm a philosopher, and for me, it's like, yeah, I understand science. Like I read a lot of Richard's books, and I understand his arguments, and I understand, like, for instance, his book, The Greatest Show on Earth.
Yeah.
But the Grand Design and stuff like that, when you get into, like, physics, that was a little, like, I had to read that and then keep coming back to it, like, take it in doses, because it was just so lofty, so, like...
Lofty is the word. Yeah, anyway, I won't...
I would say, like, just, terms that I wasn't familiar with, and so
these are weird concepts, and my book is very short, which I think is important for a physics book because it's intimidating this long. But I do try, and I think these concepts are so unfamiliar and in many cases confusing that I try in my book to very carefully, step by step, go through why we think what we think, and you can let me know at the end whether it's comprehensible. I mean, I'm sure there's parts of it that have to be read twice for you really want to understand it, but I try to give a brief but at least cogent argument for why it's reasonable to to understand what we understand today.
Right. Well, I mean, I'm just saying, I'm really enjoying it so far. It's an easy read. It's not something that you're struggling to get through, or and you make the subject, something that the average person can grasp, and you do it in a way that kind of keeps the attention there. Because sometimes, I read these books, like I said, The Grand Design would be one of those, that it's just so dry, and I can't, it's hard for me to keep my attention there. But with this book, I didn't have that. It was very, I like how you went into Einstein, and dispelled in the beginning there, he kind of dispelled a misnomer about, Einstein. So that was really cool, and I did skip ahead to the end already and read Dawkins.
Read Richards afterward.
Yeah.
It's not a novel, so it's not as if you'll spoil it by doing that. But
Right.
I like to. Well, I've been told people told me they've read it in a night, and I love that idea that you could pick up a physics book and read it in a night and find it interesting enough to continue through the pages. I try to intersperse the science with some interesting history because the people are fascinating, and also with jokes whenever I think they're good ones.
I actually probably could have read it in a night, but I'm working on a bunch of 6 different books at the same time from the Stoics.
Okay,
so,
the Stoics have got to be a lot harder to read than my book.
Yeah. Well, yeah. Some of these are a bit. Well, I got some new translations. So I guess I wanted to get on to some questions, if you don't mind.
Sure.
There's a question. Well, actually, Shelley, do you have that question from Jeff D?
Yes, this is from Jeff D. from the Atheist Experience, and he wants to ask you, says, there will come a point in the future where scientists in our galaxy will no longer be able to observe the evidence of the Big Bang. Is it possible that something similar has already happened to us?
Okay, yeah, I talk a lot about that in the book, how in the far future all the evidence for the Big Bang will essentially disappear. They might be lucky, but what's possible. It's certainly possible that there are things that we could have seen earlier that we can't see now. And if we sort of know of one, we weren't around at t equals 0, and we don't have a theory of quantum gravity, and therefore we have to try and infer what happened at t equals 0, and we don't yet know. And we're hoping to find remnants of that so that we can have some observables. But it could be that we'll never have a direct empirical observable associated with t equals 0 in the Big Bang. So I tried to give some cosmic humility there, in the sense that there are things that we are when we talk about the universe, and when we study the universe, which is what I do, then we are restricted by the fact that we are stuck in one universe. There may be more than one universe, for example. And so we are stuck at a time that 13.7 billion years after the Big Bang. There are limits on what we can observe, and those limits are fundamental and put limits on what we can know empirically. And so we have to realize that there can be incomplete pieces of our puzzle that we may not be able to detect directly. And the hard part, but that doesn't mean, the thing that is really important to realize is that doesn't mean that everything we know is wrong. I mean, just because they won't see the Big Bang, evidence of the Big Bang in the future, doesn't mean that when we see evidence for the Big Bang is wrong. Their ignorance is from things they can't see, but we can see a lot now, and everything we see tells us there was a Big Bang. So whatever we learn in the future, that we can't see now, will not change what we know to be correct now. It may refine our understanding of the far future, or the earliest moments of the Big Bang, or the existence of other universes, or whatever. But it won't negate the evidence that we already have. But we should realize that our evidence is incomplete, and in some sense always will be, because we are limited by the circumstances of our time and space, and that's just life.
Right. Yeah, and that's humility, and I don't think humility is some well, if I can talk, some sort of inferiority complex, but it's really just seeing yourself for who you really are and all your weaknesses.
Well, in fact, that always amazes me when theologians and other, or at least fundamentalists, talk about the conceit of scientists who say they know everything. And how can they know that there's no God and all the rest? And the point is, I think we're the exact opposite. We're happy to point out that we don't understand things. And as I often say, the greatest state to be in, if you're a theoretical physicist, the most exciting two states to be in are wrong or confused. Because that means there's more to learn.
And just being okay with not having an answer at a particular moment, because that means there's a mystery to uncover.
And mysteries are much more fun. It's the search that's more fun than the finding.
Okay, so there's this next one's going to kind of go into quantum mechanics, and this next question actually comes from Johannes Rayatz, who is claims to have a BA in quantum physics, and he has his own little flavor of deity that he likes to pump on YouTube. I guess I've heard that he thinks God is some sort of wave function or something. I don't know. It's some out there thing. He even went on the Atheist Experience not too long ago and brought up this concept or whatever. So anyways, he wanted me to... I'm a determinist, okay, to like the max. So this is not only for him, but this is also for me. He wants me to bring up the uncertainty principle and determinism. And he's curious to see what your answer will be. He follows after Bell. Whoever that is, whatever.
Bell's work is correct. I mean, it's not, the physics isn't like you follow trends. There are things that are right and there are things that are wrong. And Bell's theorem is as a mathematical theorem, is profoundly important, and it means that quantum mechanics is stranger than you could ever possibly imagine.
Right, but I guess my question...
Let me
sure.
come back to... I'll give you an answer. I know what his question's going to be, so I'll give you the answer, and you can tell me if I was asking the right question.
Okay. But
people think that quantum mechanics implies the world is not deterministic, and that's not true. Quantum mechanics is involves second-order differential equations, partial differential equations, that are completely deterministic. You give initial conditions, and it'll tell you exactly what will happen in the future. Now, what they describe is something called the wave function. So the wave function of things is determined. Now, your observations are not determined. When you observe something, what the quantum mechanics will tell you is a well-defined and exact set of probabilities that you will measure certain outcomes. But you can't say each time which outcome will happen. So the world appears to be non-deterministic in the sense that your measurements aren't determined. You can't determine with certainty what your measurements will be. But the underlying evolution of the system is completely deterministic. And so quantum mechanics doesn't get rid of determinism, or for that matter, free will. I think that free will is also an illusion. That
so do I.
In a world that looks like we have free will, and for all intents and purposes, we may well have free will, but at a fundamental level, I certainly don't think that free will exists.
Okay. I guess more of my questions are, let me just kind of frame this first. To me, when someone says possibility, probability, random, chance, indeterminacy, to me, what that means is that we don't know yet how something is caused. And I guess how Rayatz is using it is no, this is actually, in all actuality, we've proven through quantum mechanics that this is actually uncaused. It's totally indeterminate. It can never be. In other words, it's not just a lack of knowledge.
Well, he's right about that. There's some things. Quantum mechanics isn't a theory of hidden variables, where if we knew things better, we'd be able to predict the results of experiments, each experiment exactly. He's absolutely right. The quantum mechanics doesn't say that if there's more. It says there are fundamental things that are unknowable. They're unknowable because the underlying system hasn't determined them. Electrons are not spinning in one direction or another before you measure them. They are spinning in all directions. And when you measure them, you force them to be spinning in one direction or another. But before that, they were literally spinning up and spinning down and spinning sideways and left and right. And it's as crazy as that seems, quantum mechanics tells us that's happening. So, and so it's not a question of knowing more. Einstein used to think, well, quantum mechanics is somehow wrong. If we knew more, we'd see it was like classical mechanics, a theory where every observation is exactly predictable. But that doesn't get rid of determinism. So he's right about what he says, but in my opinion, that doesn't get rid of determinism because the underlying equations are completely deterministic. It's just our observations that aren't.
Okay, so but again, it isn't a question of just a lack of knowledge.
No.
And then how would you actually know that? I mean, let me kind of frame it this way. If let's say a particle just popped up out of nowhere, okay? And so it's popped out of nowhere. At what point do you give up and say, you know what, there is no cause for this particle 100 years, 1,000 years? And if you do give up...
We don't give up. We say the theory explains that there's a certain probability at each point in space that a particle will pop out of nowhere, and we can calculate that probability exactly. We can't say when it'll happen, but we can tell you with an exact certainty what the probability is that a particle will be created. So the theory predicts probabilities with 100% certainty. It doesn't, and the point is, and it's Bell's theorem, which we can't go into in this program, tells us that in fact, any assumption you make about, well, the reason you're getting this crazy result is because there's something you can't see that's being hidden. You can show mathematically that if you assume that, you will come up with predictions which disagree with observations. So you can show conclusively that there aren't things called hidden variables. There aren't things that we can't see that would make the theory sensible. Quantum mechanics is just not sensible. That doesn't mean it's wrong. It just means that the world is not the way we'd like it to be. That's all. So
it's literally at some level undetermined, uncaused?
I don't know what you mean by undetermined and uncaused. The theory tells you that something will happen with a probability X.
Well, I mean, like you were saying that these things, I guess protons or whatever, spin, and you can't tell, which way they're going to spin, except when you look.
Until you look.
Right.
50% of the time, when you measure it, you'll find it spinning up, and 50% of the time, you'll find it spinning down. I can tell you that with exact certainty before you do the experiments. And if you do it 100 times, you measure it 50 times up and 50 times down, within statistical accuracy. But that I can tell you with 100% certainty, but I can't tell you each time whether you'll measure it up or down. And you may not like that, but that's just the way it is.
Well, no, I'm just saying just because you can't tell me doesn't mean that that there isn't something we don't know yet. That
no, but what you can then say, but really the electron is either spinning up or down beforehand, and I know that. Well, it turns out I can do a series of experiments that will prove to you that can't be the case. And that's what Bell did in his remarkable paper.
Huh. Okay. So he determined that something was indeterminate, not determined.
Determined that there's not that things aren't behaving in a sensible way when you're not measuring them, is what he determined. That objects are doing many different things at the same time.
Okay, but is something causing them to do that?
The theory tells you that their motion, set of possibilities, the probability that they're doing different things is determined by the theory. If you want to call that a cause, you can call that a cause. It says that they're constrained to be in a predictable way doing all the different things they're doing with different probabilities if you measure them.
Huh,
so they're doing them all, but when you measure them, you'll measure them with a given probability to have done one or the other.
That's fascinating. I don't want to spend too much time on that because I can.
It's pretty. Believe me, you hit one of the most subtle and confusing parts of quantum physics. So.
Well, I think humans like everything wrapped nice and neat too, and so that part of determinism I think is good for those people that are like that. I'm a pretty logical person, and so I like things to be wrapped up and make sense. And when you say something is not determined,
makes sense. But you may remember when I debated William Craig and the religious guys have made hay over this because they don't understand it. They're just their minds are so closed, they don't understand it. I took off my shirt and had this T-shirt on, which said 2 + 2 = 5.
Right.
Instead of extremely large values of 2. To point out that classical logic is nice, but it doesn't mean the universe has to play classical logic. And in certain cases, it doesn't. Just get over it.
Right. Yeah, I mean, things are the way they are, and you have to, I call myself a realist more than anything else. I even have a site called Ecclesia of Realism, and it has my position on determinism and all these different things on ontology and different issues, so that people, if they want to know, or instead of strawmanning me, I can just send them a link to that and say, go read my position. And I always say that a realist is somebody who seeks to understand and to represent reality as it actually is, regardless of what you want it to be. And reality just is what it is. Things, I think, if theologians could wrap their mind around the fact that things could not be any other way.
Well, then maybe they could be another way, but not in our universe. But I think I say it that way. Well, very similarly, the universe is the way it is, whether you like it or not. Just get over it.
Right. Well, I mean, I would just say that well, damn, what are the odds that so and so would be the Queen of England? Well, 100% if you're the Queen of England. Things.
But if you ask the odds, if you ask me to calculate the probabilities from scratch that you and I would be talking on Skype right now, I could show you it'd be 0.
There you go. Yeah, I don't know. I just see things as is. I don't really see oughts other than in our brains, and I think we project that onto the universe. We think things ought to be a certain way because it fits the way we want things to be, but that just is not. Things just are, regardless of what we want them to be. And I think if we can just grasp that, we can grasp reality. And so I don't know. That's how I kind of see the world. So I just try to force my worldview around the way things are and not the way I want them to be. So so yeah. Yeah, go ahead. Sorry.
Oh, I have another question. It's from Fabian Giacomelli in Australia. And he wanted to ask, what's the next big discovery in physics that will affect our day-to-day lives? And how do you think it would impact our lives?
I always tell people, I was going to ask that a lot, if I knew what the next big discovery was, I'd be That's the great thing about the universe, is it surprises us. We don't know what the next big discovery is going to be. As I said, doing it, I would have made it if I'd known. So I have no idea, except I can say that every time we open a new window on the universe, we're surprised. And we've just opened a few new wonderful windows. One is the Large Hadron Collider in Geneva, which is exploring matter and forces on a scale that we've never been able to observe before. And I expect we will get tremendously interesting surprises coming from it. We are, every time we put a new telescope up and look at the universe at earlier times, or look at new signals from different particles coming from the universe, we're surprised. I think when we see gravitational waves coming from black holes or other objects, we will be surprised. I think our ability to manipulate atoms on a fundamental scale to exploit the weirdness of quantum mechanics will produce interesting objects, so-called quantum engineering, maybe quantum computers that will allow us to calculate at rates that are unheard of today. And maybe the ability to understand biological systems, how proteins fold and why DNA doesn't get knotted up, and all sorts of things which are really physics problems will reveal to us how biology works. And so there's lots of exciting frontier areas, and who knows where the next breakthrough will be.
So in what you do, you teach, don't you? Aren't you professor
I try to.
I mean, in a college, right, or in a university?
Yeah, I'm a professor at Arizona State University. I'm the director of something called the Origins Project here, which studies everything from the origins of the universe to the origins of consciousness. And I'm professor in the School of Earth and Space Exploration and the physics department as well. So I have graduate students, and periodically I actually teach classes.
Well, I mean, I really like your teaching style because, I mean, like I said, you it's not boring when you're teaching. You know, it's not like, oh, you're just going to fall asleep.
Well, it keeps me awake, so I it'll keep others.
Sure, you throw in little puns there, and here and there, and kind of,
And also, you can tell how passionate you are about
exactly.
the topic and about spreading the information that you have. It's great.
Well, I am passionate about it, otherwise I wouldn't do it.
So, this may be a really stupid question, but I mean, would you classify yourself as an atheist?
Well, no, I don't classify myself as anything, but not particularly in the sense that I can't. If you were to ask me to classify myself at all, I'd use a term my late friend Christopher Hitchens would have used, which is I'm more of an anti-theist. Anyway, I can't say for certain that there's no God or divine intelligence in the universe, but what I can say is I wouldn't want to live in a universe with a God.
Right.
So, I mean, I just find that idea so reprehensible and disgusting that I wouldn't want to live in such a universe. But no, I can't say with absolute certainty that there isn't a God, just like I can't say with absolute certainty that there's not a teapot orbiting Jupiter. But what I can say is there's no evidence for one, and that's all I can say.
So, I mean, would it be fair to say that you're agnostic in the sense that you don't know that there isn't a God, and you're atheist in the sense that you don't believe there's a God?
Well, I don't think the word believe is an appropriate word for science. I wouldn't call myself agnostic. I would say, in physics, we say, is something likely or unlikely? And we know very few things with absolute certainty. And everything I know about the universe tells me I think it's extremely unlikely that there's God. Moreover, I can tell you that if there were, that God is irrelevant to everything I understand about the universe, so I don't really care about him. And that's the thing about, as Steve Weinberg says, most scientists don't even think enough about God to know if they're an atheist, because God is completely irrelevant to everything we do.
Right.
So God, it's the most infinite, kind of useless thing to worry about, so why even think about it?
Yeah. If it's not manifesting itself in the universe in a testable way, then what's the point of even talking about it? Yeah.
Right, and here you have this character that is, just utterly infantile, that throws tantrums and orders the deaths of infants and such. I think it would be a downgrade to have that kind of God versus a God who would actually, I don't know, create something like we see in the universe. I don't see that type of God. I see that type of God, if that turned out to be true, to be like just this big letdown. Just
it would be a disappointment. But as I say, right now, the great thing about God is completely ignorable. If she exists, then it doesn't really matter to me anymore, as I say, than whether it's a teapot orbiting Jupiter. They're both about as relevant to everything I understand about the universe.
Right. So, how much flack have you gotten over this book? I mean, especially the title, and then the video. I know the video got a lot of views on YouTube.
Yeah. Well, yeah. I mean, I get flack all the time, so I guess it doesn't matter. People are for the most part polite. There's some people who are incredibly vicious in their emails, but
yeah.
The flack I get is people who are patronizing, who say, "Oh, you just don't understand." So what are you going to say? It's usually the philosophers or the theologians. They, "Oh well, this poor Lawrence, if he just understood what we understand, then he wouldn't think what he thinks." But on the whole, there are people who are angry that I make. And what's amazing is, nowhere in the book do I say the universe came from nothing. What I show is that it's possible.
Right.
But it's amazing that when you just suggest something, if it suggests there's no God, you're automatically taken to be a dogmatic atheist. And you're dogmatic and you have this goal. And all I always say, something's possible. And it's the fact that it's even plausible is so remarkable that it's worth sharing with people. But it amazes me that the reaction of people is immediately, "Oh, well, that's dogmatism, and I don't, and you think you know everything, but you don't know everything." And the whole point of my book, as you pointed out, I think somewhere, is that I keep pointing out the uncertainties, what we don't know and what we know. But what we do know is that it's incredibly plausible increasingly plausible that the universe came from nothing. And moreover, all of the things we measure about the universe are consistent with the universe that came from nothing. And that is remarkable, to me at least.
Right. Well, this past summer I was on Dr. James White's program, The Dividing Line. Dr. James White is one of Christianity's, I would say, top apologists. And I brought up Dawkins and I brought up evolution, and he was basically like, "Oh, you know, them scientists, they're just biased, you know," because I mentioned that most scientists are not theists, at least when you look at the National Academy of Sciences. And he said, oh, you know, they're biased, you know, pretty much. Like, he had this attitude of, like, almost like, I don't want to put words in his mouth, but it seemed that he had this attitude of, like, there's some sort of conspiracy inside of...
They assume that we have this kind of conspiracy and we have this handshake. We say, we don't want to consider anything that disagrees with us. When the thing that's so stupid about that is that they don't understand that what every scientist wants to do every single day when they go into work is prove their colleagues wrong. Because that's the only way you get famous.
Yeah.
And so it's so ridiculous to suggest that what we don't want is anyone attacking our ideas. In fact, we want to either be proved wrong or prove others wrong, because that's how we learn things. So it's just the kind of nonsense of people who are ignorant, and I have little use for it.
Now, you did another book, which I haven't read yet, and I really want to read. It was on...
Go and buy it first. Anyway, I'm sorry.
It was on... it's called Quantum Man, and it was on the life of Richard Feynman.
Yeah.
Now, you were inspired by him quite a bit, right? I think that's pretty much what got you into physics.
Yeah, sure. It's Richard Feynman, one of the people who inspired me to become a physicist, absolutely. And not just me, but many, many physicists. Yeah.
So what was it that inspired you about Richard Feynman's life?
Well, I don't know about his life as much as the person. I mean, the brave and relentless pursuit of knowledge and the enjoyment that he got from it, and the excitement he got from being able to explain what he understood. All of those things were really seductive, but were just irresistible. And the fact that he was the first. When I read about his work, it was the first time I realized there were things we didn't know. You know, when you first grow up, you know, you're told all this stuff about Galileo and Newton, and it seems like, you know, science knows everything. And I began to realize there was a lot we didn't know about the universe and a lot of things left to learn, and it was still an open field. So I guess all of that, combined with his humor and his excitement about life in general, and his excitement about ideas, all of that was intoxicating.
How old were you when you decided what you wanted to do?
Well, I'm not sure I ever decided what I wanted to do, but I when I was in high school is when I thought I might want to be a physicist. My mother wanted me to be a doctor, and she told me doctors were scientists, so I learned about science, and doctors weren't scientists. That was a big blow to me and her. So, you know, I was interested in science at the time I was a kid, but I liked lots of things, and so I did history, and I did Canadian history for a while, and so I knew that I loved science and I loved physics, but you know, I'm not sure I committed myself to even. Well, I'm not sure I committed myself even after I got my PhD, but I knew I wanted to study it, but it was probably in high school when I seriously thought I probably wanted to be a physicist for the first time.
And what advice do you have to people who are past their studying age, that have been religious for a long time and are kind of just delving into science and just finding an interest in that side of things?
Well, and you hit the key word there. Continue to find it interesting. Do whatever interests you, and don't be afraid of the truth, of finding, or don't be afraid of following nature wherever it leads. And it only makes the world more interesting and more fascinating, and things more meaningful to understand things the way they really are. So do it if you find it interesting. Follow whatever interests you, and don't stop following it.
Right on. That's good advice.
That's as good advice as I can get. I try not to dispense too much advice, but I think that's it. Too many kids are worried about jobs and everything else. So one time in your life you can do what you want, do it.
Right. So, Shelley, did you want to play something for us, or are you geared up for that, or no?
Yeah, I'd love to.
Okay.
I'm actually going to see you in April this year, Lawrence. I'm playing at the Global Atheist Convention in Melbourne.
Oh, good. I'll see you in Melbourne. Absolutely. Is that where you live?
I'm really excited. Yeah, I live in Melbourne, and I'm playing at the dinner on the Saturday night. So I'm really looking forward to the whole event. It's going to be really exciting.
It'll be quite an event. I'm looking forward to it myself, and I like Melbourne. I just spent a month there earlier last year, and it's a great place. So yeah, I'm looking forward. It's going to be a big event, and a lot of people will be there, and I look forward. It'd be nice to hear some music on Saturday night. Now I'll probably go to the bank, but I'm going to skip that otherwise.
I think there's some good comedians as well that are going to be talking. And well, I'll just grab my guitar. This is actually a song I wrote for Christopher Hitchens, and I was really looking forward to getting to play it for him.
Yeah, I feel sad that he won't be there. I was looking forward to being there with him myself.
Yeah. I guess I used to be religious until a few years ago, and only recently became interested in science because I realized there was other explanations than just God did it. So, and he really, reading his books and watching him debate really gave me the courage to kind of talk about these issues in the community that I grew up in and to sing about these things. So that's what this song is about. He always talks about in his debates how the universe is not geared for life, and that kind of shows how insignificant we are. And I also like how even in the face of our insignificance, we create meaning for our lives, and we can be powerful in the sense that we can discover things about the universe. And yeah, this song's called Apocalyptic Love Song, and it's dedicated to him.
Oh, that's great. That's just great. I can't wait.
One day the sun is going to die. For us it means no more sunsets to the universe. Just one less star in the sky. And almost all who ever lived have already died. Count the stories of love and war and hope and pain now silently side by side. Yes, I understand that my whole life is just a blink of an eye. And the history of the earth is with each moment that goes by. But this moment that I am with you, it feels like time has stood still. It feels somehow like it matters, that it always will. In 1 billion years, the oceans will dry, while somehow life may continue. It will not be known to you and I. To think we are so important is an obvious crime. We know that we are specks on a tiny dot, hurtling through space and time. Yes, I understand that my whole life is just a blink of an eye. And the history of the earth is with each moment that goes by. But this moment that I am with you, it feels like time has stood still. It feels somehow like it matters, that it always will. Yes, I understand that my whole life is just a blink of an eye. And the history of the earth is with each moment that goes by. But this moment that I am with you, it feels like time has stood still. It feels somehow like it matters, that it always will.
I'm applauding.
Thank you.
Thank you very much. That's a nice way, I think, to end this this little discussion, and it's very, very nice.
Well, Graydon Square sent me a song we'll play in the outro, just for you. So if you listen to this later in iTunes or whatever, in your little iPhone or iPad or whatever, you can hear it. So, and then her one of her other songs saved is in the intro, so you can hear that too. And then you can find links to her video and stuff on the openairatheist.blogspot.com, openairatheistpodcast.blogspot.com. And by the way, folks, I am looking for a sponsor for this show, so if anybody out there is listening to this and you're interested, please. So, yeah, I know you got to go, and I really appreciate you showing up and answering our questions. It's been a joy. It's been a privilege for sure. And you're welcome back anytime you want to come back.
Thanks. It was fun, and I'm just happy now that she's yelling because I didn't have my video turned on, and I just waved at her. So, anyway, but thanks a lot, and good luck to both of you. And I'll see at least one of you in Melbourne.
Yeah, I'll see you in April.
Okay. You take care.
Take care, Lawrence.
Okay.
Thanks, Lawrence.
There you are.
Bye.
There, James. Okay, you take care.
Hey, you too. Thanks.
Okay. Bye-bye.
Bye. Well, folks, I figured I would end this show as I usually do by reading an atheist quote. And this quote is from Benjamin Disraeli. I hope I said that correctly. The last name is Disraeli. Where knowledge ends, religion begins. With that said, folks, I'm going to go ahead now and play that song by Graydon Square. It's called Final Notes. If you haven't already, please go check out GraydonSquareBandcamp.com. It's great music. And also, thank you, Graydon Square, for allowing me to use your music in my podcasts and in my videos. Very much appreciated.
They want someone to save us, journey in the making. At unsustainable speeds, we trying to keep pace with all this information. Here for the taking, 13.7 billion years in the making. I got a transfinite number of rhymes, intricately designed, intended to be unleashed one at a time. Archaeologists recognize me as part of the find. It's amazing how you can't tell space apart from the time. And as you approach the velocity of the time gets slow. The farther you look, the further back in time you go. Fives across the board, everything is nominal. A creator causes cause and effect to fall like dominoes. These are the questions and the riddles that yearn to me. To look up at the stars and stare into eternity. I'm just looking for the final equation is all. And I'd be unsatisfied if the answer was God. A creator of the cosmos needs more than just a bad temper. His true nature coming into focus like a fast render. Try to explain, but your logic and your math centers nowhere to be found like the Tea Party's black members. I don't wanna be the average rap dude. My rhymes stay constant like light speed in a vacuum. Assembled in a DARPA lab with enough augmentations to make a science fiction author laugh. I'll assimilate the best part of your favorite rappers with species 8472 and board tactics. Hack into the digital drive, ransack it, purge all the coonery songs and whack rappers. Take it back to spitting lyrics of straight passion and revolutionize hip-hop with mass action. Last thing I'll say about light, you need to master that only things without mass can travel faster. You and I can change lives without masters. Others wanna sit by, wait for thine rapture. Make the check out to the church and find pastor. Getting burnt like they were standing behind dragsters. Socialize with other minds they might capture with techniques of manipulation and fright tactics. You might ask if a Christ who had passion would allow his dad to ask for murderer's rite passage. This is the type of position you find ravaged. I'm only asking the question that got past you. You respond with burying hate like Mike Savage till you getting carried away like flight baggage. Raw, elegant rhymes based on hard evidence from a vet of a war waged on false intelligence. Forged from a torn of racially charged prejudice, trying to avoid going the state ahead of them. Raw, elegant rhymes based on hard evidence from a A vet of a war waged on false intelligence, forged from a torn of racially charged prejudice, trying to avoid going to state that has someone to save us. Journey in the making, at unsustainable speeds we trying to keep pace with all this information here for the taking. 13.7 billion years in the making. They want someone to save us. Journey in the making, at unsustainable speeds we trying to keep pace with all this information here for the taking. 13.7 billion years in the making. They want someone to save us. Journey in the making. All this information here for the taking. They want someone to save us.